Okay, so in class, we decided that this statement was always true, which would make it an identity. So what we did not do in class is prove this identity, show that it's always true, and the way we're going to do that is to employ the unit circle, the distance formula, and some algebra. Okay? So hang on, pause the video at any point if there's something that went too quick. Otherwise, I'll just try to rip through this a little bit. What we need to start are two angles, X and Y. I used X and Y because that's what they use in your book. And I'm going to draw them on here. So for example, here's angle X. Sorry, the paper's a little splotchy. So we'll call this is angle X. And then we need another angle, which we will call angle Y, that we're going to add to X. So we're just going to put angle Y right on the end here. And this is angle Y. So we're really thinking of this angle here being to angle X, and this angle out to here is X plus Y. So by definition, this becomes cosine of X, sine of X, and by definition, the coordinates of that point, the coordinates of this point would be cosine of X plus Y sine of X plus Y. Remember, we're going to be using the distance formula. That's why we need some coordinates. Coordinates of this point, of course, is 1, 0. Now I'm going to add in one more angle down here. I'm going to take this angle Y and run it down here into the third quadrant, which will make it negative Y. And the coordinates of this point would then be cosine of negative Y sine of negative Y. Now I'm going to do a little tricky move. Wow, I didn't write that, I'm sorry. Move that there. This is negative Y, then this is cosine of negative Y and sine of negative Y at this point. I'm going to do one tricky move here and pause the video and see if you can figure out why this is true. Cosine of negative Y is the same thing as the cosine of Y by symmetry. And the sine of negative Y is the same thing as minus the sine of Y. So I'm going to use this coordinate instead and slap a little distance formula on. And what I'm going to slap the distance formula on is the following. Check this out, a little geometry. I'm going to try to connect these 2 points here. This chord of the circle, I'm going to call, well, I'll just call it the distance between these 2 points. I'll call it D1, distance 1. And I'm going to compare it to this chord across the circle, which I guess we'll call distance 2. And you should be able to convince yourself, you don't need to do any 2-column proof or anything like that, that distance 1 is equal to distance 2. So what we're going to do is we're going to use the distance formula with the coordinates, these coordinates, and then these coordinates. You use the distance formula and set algebraically, making the jump to algebra speed. Give it all she's got, Captain. D1 has to equal D2. Brace yourself for the distance formula. I'll do these two first. So cosine of X plus 1 minus 1 squared. Write that down here. Cosine of X plus 1 minus 1 squared plus sine of X plus Y minus 0 squared. That's D1, and we're going to set that equal to D2, which cosine of X, just squeezed on there, minus the cosine of Y squared. Oh, you see some foiling coming. Oh, I'm sorry. I got to try to pay attention to that a little better. And then the other half of the distance formula are the Y coordinates. We've got the sine of Y as this Y coordinate minus the sine of Y. So we have sine of x plus sine of y. Sorry, this is the sine of x. And that's squared. Whew. Take a second and pause the video and make sure you're okay with all that distance formula. We've now squeezed out of the unit circle this rather impressive chunk of algebra here. I'm going to scroll this down. Now we're going to mash this around here. We're going to do some foiling. We've got this thing, we're going to foil it. I'm going to do it pretty quick. Try it on your own, see if you match. This is going to be cosine squared of x plus y minus 2 cosine of x plus y plus 1. That's sine squared. That doesn't need to be foiled. Sine squared of x plus y. Next, cosine squared of x minus 2 cosine x cosine y plus cosine squared of y. That's this whole beast here. And then, oh, that should be a plus. It's a distance formula. Sorry. Plus, just what I need, a sign mistake. Sine squared, kind of going on to the next line here. I'm foiling this beast here. Sine squared of x plus 2 sine x sine y plus the sine squared of y. That's sort of an intimidating line of algebra, but alas, what do you spy? I spy with my little eye a cosine squared and a sine squared. Cosine squared plus sine squared, do-do-do-do, do-do-do-do, ding, 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 that equals 1. So these two things together make 1. That 1 is 1, and 1 plus 1 is 2. So this, and this all together make 2. The other side, we've got cosine squared of x, sine squared of x, that's 1, plus 1, that's 2. This all cancels. Yes, I love canceling. Cancel, 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 cancel. All that on the right hand side is 2, and that cancels with this on the left hand side, which is 2. And when all of that canceling dust settles, I'll just write down what we got left. Negative 2 times the cosine of x plus y. That's all that's left on that side. Over here we got negative 2. Oh, maybe you're already seeing where this is going. Cosine x, cosine y, plus 2 sine x, sine y. Woo-wee! Now all we're going to do is divide everything by negative 2. Because remember what we were looking for was this cosine of x plus y. Divide everything by negative 2 and we get the following. Cosine x, cosine y, minus sine x, sine y. Now, I know we're done. That's what we started with. Go back up to the top of the page or look in the back or from the homework. You should recognize that this is the thing that we were trying to prove was true. We have proven it. Yes, it was a little involved, and it was quite a lot of fun. You should do it yourself because I really enjoyed that personally. The good news is we don't have to do this again. It's proven. It's done. This we can tuck away into our toolkit. Done.